Right, it's gone 10 o'clock. Good morning, everybody, and welcome to another training session with LuxPower. I'm your host, Andy. I just want to say thank you to everybody who is joining this morning. I see we don't have a very big audience, but the session will be recorded and it will be available on our training channel on YouTube. So look out for the link for that. And a special shout out goes to Iman. Welcome to my channel. Okay, so this morning we're going to be doing the LuxPower. It's called the LSP 100, and it is not a new product in our range, but it's a product that we're going to be introducing to South Africa, and it's particularly aimed at the commercial sector. So I'm going to show you a short little video, and then we can get from there. Basically, what we're seeing here is this is a solar power generation farm for one of our clients in Japan. You will see that the battery cabinets are branded GT. It's a OEM brand that we do for this client. And what you're seeing now is a side view of all of the battery storage. Now the camera is panning across the inverters. So the first inverter you'll see there with the GT on it, that's our LSP 100, which has been branded for the client. And that's mated with a Huawei grid-tied inverter. So this particular station is, I think it's great. I'm not quite sure exactly how big the station is, but it is it's a multi-megawatt station. And yeah, that's basically to show you what the product is capable of doing. All right, so now we're going to jump straight into the product information. Like I mentioned earlier on, the product is called LSP 100. So it's a 100 kilowatt DC to DC inverter. That's very important for you to remember that. It's not an AC generator, inverter, sorry. So it doesn't put out any AC power. It's purely DC to DC. So it's a retrofit or an add-on to an existing system. And it is designed in such a way that it can augment or improve an existing or an older installation where you have already have a grid-tied inverter installed, and you want to now include batteries. All right, so let's. So all right, so the contents of the presentation will be the introduction, the key features and innovations, the installation and maintenance, and then obviously use case uses and applications. All right, so the challenge of grid-tied systems are potentially that they are great when the grid is active, as well as when you have sufficient solar to generate power and push power back into either the grid or into your own installation. So, high-powered grid-tied inverters were widely adopted over a large scale. And essentially, they are, by the phrase or by the terminology that they are grid-tied, it simply means that as long as the grid-tied inverter or the mass energy inverter is connected to the grid and it can detect the grid, then it will function. But in the absence of grid or in a load shedding situation, the grid-tied inverter by law has to switch off. So none of that topology will change by adding on the LSP 100. The LSP 100 simply just gives you an opportunity to go to an existing mass energy solar farm and add battery storage. So if we look at the challenges with the grid stability today, the limitations of traditional grid-tied systems are becoming increasingly apparent. With a growing penetration of solar power, fluctuations and grid stability have raised concerns. And like I mentioned earlier on, the lack of energy storage in existing systems means that the systems can only really generate power when the sun is shining. So by adding the LSP 100, what you're going to do is, I will show you here in this diagram. Before the retrofit, you have your PV here. You have the MPPT tracker in your existing grid-tied inverter. And then you have your DC to AC inverter here. And it'll then put out your power as it's designed, either in in three-phase and rated at the power that it's designed for. It'll obviously convert the PV via the MPPT trackers from DC to AC and put it out to grid. By adding the LSP 100, you're going to be able to add additional PV because, and I'm going to go into that step a little bit later, but you'll be able to take the existing PV that you've got, and you may be able to add more PV because of the input variance or range of the LSP 100. And then this is where the DC to DC side comes in. So it takes in PV, and then in the first, on the one side of the inverter, you have your DC to DC inverter, where it's putting out the same PV power to your existing grid-tied inverter. And it's also taking DC from the PV and converting it to a high current DC to charge batteries here. So it can, so you'll now be able to double up on your PV installation. One half of it will go to the inverter and the other half of it will go to the battery. And then from there, obviously, you have your power going out, which can either be fed back into the grid or it can go into the load. You might be thinking, what is the purpose, what is the use of having something like this? Well, the great thing is now you can turn your existing grid-tied inverter into a battery storage system, which will only obviously work when the grid is on. But the ideal thing about having the battery storage is that you are able to store excess energy into your battery farm or your battery storage. And then when it's on a cloudy day or when the load demands, you can discharge the battery via your inverter and push it your load or put it to grid. Or alternatively, after the sun is set or before sunrise, you can discharge the battery and put it, convert that signal to a PV DC signal and essentially trick your on-grid inverter into believing that the sun is shining, and it'll then invert power. And once again, this will only work when the grid is active. So the grid has got to be on, right? This is not a load shedding solution. It's purely a solution to convert your existing grid-tied installation to a battery storage facility without having to change the inverter. So the needs for the upgrades, obviously, as solar energy becomes more mainstream, the need for systems that can not only feed into the grid, but can also store excess energy has emerged. And this demand is driven by the desire to optimize energy utilization. And obviously, there's a growing demand for reducing dependency on the grid. Obviously, if you already have an existing situation, you can store your extra energy into the batteries and then discharge them before sunrise, after sunset, or during the day to compensate for poor solar yield. All right, so the LSP 100 was developed as a cutting-edge solution for retrofitting. And as far as I know, going back, I think it's probably 2 months ago in one of our presentations that we did, to my knowledge, it's only LuxpowerTek and another state-owned or military-owned company in the US that has developed a product very similar to this. I'm not aware, and I stand to correction, I'm not aware of any other products by any other manufacturers or competitors of ours that essentially do a product just like this. Okay, so I see we've got an interactive video here.
Serious.
Sorry guys, I'm going to stop that for a second. I needed to mute people. Right, so there you go. That is quite an intense and brief introduction to the LSP 100, and we will go through it in detail in the next steps. All right, so let's have a look at the key features. This is the bottom view of the inverter. As I was mentioned in the video, this inverter is IP65 rated, so it can be placed outdoors. In the previous video that I showed you with our Japanese installation, we've got a solar farm in Japan, one or two of them, I think, and then in Australia as well. We've got a client in Spain that has recently bought a few units, and they're going to be building a solar farm there. And the LSP 100 is also a very, very hot favorite for our clients in Brazil, who have shown intense interest in this because the grid-tied market in Brazil is a very, very big market. Right, so if we have a look at the bottom of the inverter here, we will see on the left-hand side, we will start with the things that you guys are normally familiar with. You have the USB port here for LTD update firmware and obviously for servicing from our technicians. Then the standard dongle here, obviously we're looking at the machine from the bottom now, so you can only see the bottom end of the dongle, but that's the dongle there. And then here you have the communication port interface, and these here are the battery inputs. So you will notice that the machine has 4 rotary DC switches, and the DC switches are obviously for the PV and the battery connections, because this inverter is only a DC inverter. It's got no access to or is not connected in any way to AC. But you will see that it has a set of PV inputs here and a set of PV outputs here, and you'll see that the PV inputs are double the size of the output. And that's potentially because the 100 kilowatt inverter can take in 100 kilowatts of PV for the battery, and it can take in 100 kilowatts of PV for direct transfer to the PV side. Remember, in that little video that we saw there, you can put in 200 kilowatts of PV here. 100 will be transferred straight across to the PV output, and the other 100 will be used for battery storage. So how does the LSP 100 then couple or piggyback with an existing grid-tied inverter? Well, it's quite simple. You have your PV input coming in here, and you have PV input here, and then it has PV output here. So when the PV will be used to charge the batteries, and when the batteries are fully charged and you want to discharge battery, it will then push the battery via this coupling here to take in DC power and push it out on the PV output side. Okay, that's how it works. It uses this input here to take in DC, charges the batteries via here. It also discharges the batteries via there and pushes it out on the output side. So you can have in a sunset or before sun, or in the absence of sun, in the presence of grid, you can discharge your batteries into this port, and it'll put out a PV signal in the output, thus convincing the on-grid inverter that the sun is shining. It will then obviously invert that PV input into AC power, and then either feed it to grid or feed it to the load as it was designed to do. All right, so the front of the inverter, many of you guys are familiar with this. It's a very typical and universal screen, especially on our 10 and our 12 kilowatts. It's very similar to that, and the layout looks exactly like the monitoring system. It's a colorful screen, it's a touch screen, and it provides intuitive interface, making it easy to monitor the system. And it's also touch control for easy operation. And under the maintenance section also, it is user password protected so that we don't have any unnecessary tampering. All right, so the features of the system. I'm just going to mute some people. Hey guys, if you have joined, or if you can see that your microphone is not muted, please mute it for me because it interrupts our presentation. Right, so we have a look at the features here. It's a DC coupled system with a grid-tied system. It's compatible with most grid-tied brand inverters, and it allows for system upgrades. And I must point out to you again, this is purely for commercial type or industrial type installations, either where you're doing a solar farm or you've got a very big installation where a customer already has a 100 kilowatt or 200 kilowatt grid-tied inverter and they want to add additional battery storage to the system. This is what they're going to be looking at, right? It's got robust environmental adaptability with a IP65 rating, high energy capacity storage with 100 kilowatts. So each inverter can host up to 100 kilowatt hours of battery. It can charge and discharge those batteries simultaneously while also inverting 100 kilowatts. So the inverter essentially can process or work through 200 kilowatts of power at the same time. Right, it's got 24 MPPT inputs and 12 outputs. So the 24 MPPT inputs are for the 200 kilowatts of input power from PV, and the 100 kilowatts is for PV output. All right, and then obviously the inputs are split between one input goes to the output and the other one input goes to battery. All right, and then we've got smart control and monitoring. Many of you guys are familiar with our monitoring system. And at the end of the presentation, if I've got enough time, I'll actually take you to a live demonstration of what the monitoring looks like on an LSP 100. So here we're looking at the benefits, which is cost savings, scalability, and grid stability. Cost savings, it's a given. With a rising cost of energy, especially, we've had a very big price increase, not big, but I mean, it's 12% in May this year, or sorry, July. And I believe there's a proposal to have another increase around about September. Scalability, you can start off with one unit and you can scale them up. In the video that I showed you in the beginning, that particular installation was it was more than a megawatt. And you can scale them up to the size that you need, and I can confirm with you by inquiry exactly how big we can do our scaling, because the inverters are paired with a grid-tied inverter. They're not connected in parallel to each other. So that's particularly besides the communication, that's particularly a good thing. And then obviously for grid stability, the inverter, as long as the grid is on and the grid-tied inverter is working, then you have the ability to charge and discharge your inverter. All right, so this looks at a typical electricity saving scenario. So here we have your existing mass energy inverter, then the retrofit 100 kilowatts, so the PV comes in, goes to there, it charges the battery, and then it puts out a PV signal here and goes into your grid-tied inverter, which then converts it to AC, goes through a meter, and obviously either through a transformer and back into grid, or it can go directly to load via this line here.
Hello,
so what we're talking about when we look at the graph here, this is a typical installation without an inverter. And here you can see that surplus solar is never used. This green part here is never ever used because the load or the demand is only the stock khaki section here. But if you had to fit an LSP 100 with a battery storage, you would be able to utilize the section here, which is now this portion, to charge the batteries. And you can then discharge the batteries during these blue portions here, which means before sunrise and after sunset, you'll be able to do that. So now your load compensation, instead of looking like this graph here, it looks something like this, where you can discharge your batteries and have solar harvesting over all of this time here, which is quite handy. So I'm just going to have a look and see who is. We still need to mute some people here. All right, so this is a typical layout of a little solar farm here. Each of these inverters here is 100. And then each of them have their battery storage, as you can see there. And the harvesting is done through, and then obviously it's pushed out either to the grid or to the load. All depends on how you particularly want your layout to look. Right, so installation considerations. All installations procedures must be carried out obviously exclusively by professionals. And the other main thing that we need to be cognizant of as well is that we have municipal and regulations that that you as an installer or an EPC need to be mindful of. So we always encourage that you follow the guidelines and the laws which rule any solar installation, particularly with the applications, with how it's built, how it's designed, and then the utilization of the installation. Okay, the chosen installation site should be sufficiently sturdy to support the inverter's weight and over an extended period, because these things are designed to have a payback in excess of 10 years. So obviously the way the plant is built and designed, you have to be cognizant of all of these things. We can operate, the LSP 100 can operate in ambient temperatures of -25 up to 60 degrees Celsius. And obviously, as an installer or as an EPC, you're going to make sure that your installation is suitably protected against the environment. Adequate space should be left in front of the inverter to facilitate easy data observation and maintenance. And obviously, this is the crews that come afterwards, once the installation is done, is to make sure that flow of the design, of the installation allows for easy access to the machine for servicing and for programming, should it be a remote site. All right, and then these are our working modes. In the little video that was one of the slides, it also shows you this. We have self-consumption mode, which is the default setting. Then there's charge first mode, there's time of use mode, PV cell mode, and constant output mode. And any one of these modes can be selected, either pre-programmed or they can be programmed remotely. All right, and then we have remote monitoring. Many of you are familiar with our remote monitoring platform. The LSP 100 works on exactly the same platform, and it gives you multi-level user management and auxiliary accounts, real-time monitoring, alerts and remote control, intelligent energy management, and obviously automated support via our live monitoring, our call centers, and obviously our Q&A bot, which we are developing day by day. All right, so user cases and services from LuxpowerTek. This particular one here was installed in Japan. It's one of our installers there. And these photos were obviously taken during the installation period. And I know that we do have another site in Australia as well as one currently being built in Spain. All right, so, why go with LuxpowerTek? Obviously, it's a unique product to us, and I'm sure that there are other manufacturers who are looking at developing something similar. But we have definitely had this product on the market for a couple of years already, so we know exactly, it's a well-defined and refined product. And we've managed to do significant upgrades to the logic of the machine. So we are introducing a machine to South Africa that's not new. It's been tested, and we have the pedigree to go with it as well. You're getting solid product quality. You're getting after-sales service. You're getting training, as well as the ability to update and improve your installation. All right, guys. So thanks for going through this very brief training with me. What I'm going to do is I'm going to see if I can call up a LSP 100. I know that the site that we're currently using it in at the moment is it's already sunset there, but it should be able to give us an idea of what the particular yield looks like. Okay, so just give me a second. I'm going to call up a site. Let's do a screen share again, so you guys can see exactly what I'm doing. Okay, so here you can see that we have, and the LSPs, we've got quite a few machines. You can see all of them that are connected. So I'm just going to go. Oh, somebody's just telling me they can't see the screen. All right, so here we go. You be able to see it now. All right, so let's have a look at this particular one. So this particular machine here, as you can see, is connected. There is no PV at the moment because it's in Japan and it's currently beyond after sunset there. But we can have a look at, if we have a look at the solar yield on this one machine today, it yielded 265 kilowatt hours. That's 265 kilowatts in one day, its yield. In its total life, it's done 145,000 kilowatts. That's 145 megawatts of in its life. It's discharged 116 megawatts, and it's exported or sold 133 megawatts to the grid. Okay, so this particular machine today, of its 265 kilowatt hours that it yielded, it exported 83 and obviously used the balance under its load consumption. And that's just one typical machine. Like I said, you can see on if we go back here, I didn't share the screen at the time, so you wouldn't have been able to see. But if I just show you LSPs to give you the peace of mind, you can see that we have everywhere where you see connected here, it's a machine that is currently in the field and is connected. So the question mark ones are on another server. But we have, as you can see, we've got 116 of them out in the field already. Okay, guys, so that is the end of the presentation. I'm going to have a look at the chats to see if there are any questions, and then I'm going to answer those. There's only one question. Is the link of the session going to be available after the meeting? Yes, most definitely it will be available. Kathy in our office in Shenzhen will make sure that the recording is posted in our training catalog on YouTube. So if there are any questions, you can reach out to me. You can speak. You can reach out to us via our website. LuxPower does have a .co.za website now. It's LuxpowerTek.co.za. We also have LuxpowerTek, so it's TEK with the K.com. We also have our local office has a call center. The number is 021-490-5000. You can call us anytime during office hours. Our guys are ready to take your calls. And that's not just for the LSP 100, but it's for all of the products in our product range. And then very soon, we will also activate our online bot, our chat bot, that will be able to answer some of the questions that you guys have. We are very, very happy with the support that we're getting from you guys in the field, especially with the sales. I want you to know that we appreciate all of the sales that you guys do. We appreciate your support. And I just want to remind you guys that there are some questions that have come through recently this week where people have been asking, can our machines be connected as grid-tied machines? And I'm talking about our residential inverters. Yes, all of them can be, with the exception of the SNA 5000, which doesn't have an external CT. They all run without battery. So, we're seeing, at the moment, we've seen a slump in the market since we haven't had any load shedding, which I see as a good thing, because it's kind of, the market is in a relaxed state at the moment, but we should focus our energy on selling product into the energy saving market now. So the same customers that you have been targeting with load shedding solutions, these are the people that you're going to go back to now. We've never seen prices this low on solar panels, on inverters and batteries. Now's the time to go and speak to your customers and get them geared up to start looking at energy saving, because you can certainly do an inverter installation without any batteries. All of our inverters can run without battery. Obviously, they have to have solar panels connected, and the panels will then be used as supplementary power to power homes during the day while the sun is shining. and that'll certainly ease the burden on the cost of energy. And you can do a graph or a table and explain to clients how in the space of 1 year you'll be able to save up enough money to do a battery. Obviously, the ideal solution would be to maximize the panels and then just to have a little battery in place, even if it's just a little 5.1 kilowatt hour battery. Put that in place, and you will then be able to store energy into that battery, and then at night discharge it as well. And then you're going to see a better a return on investment on your installation. All right, so I'm going to wrap it up in a second, but before I do, I just want to make sure that I've answered all of the questions. There is one more question that has come through. Can you please explain how the LSP 100 connects to the essential load in the absence of grid? Okay, so that's a very good question. The LSP 100 is not an AC inverter. It's a 100 kilowatt DC to DC inverter. So it's a retrofit. It's for commercial use only. You have to have a grid-tied inverter that it pairs with. And all the LSP 100 does is you can maximize your PV up to 200 kilowatts. It will use 100 kilowatts of that battery, of the PV power, to charge batteries. So you're going to have to do a commercial battery installation as well. And the other 100 kilowatts of PV it will use to feed directly to the grid-tied inverter, which will then do the inversion of power. How the 100 kilowatt will benefit you is you can then, when the sun is set, so in other words, in the early mornings or in the late afternoons, and think about a distribution center, for instance. Our Cape Town office is based right next door to the Checkers distribution warehouse. They've got a massive solar installation, but these guys work before sunrise, and they also work after sunset because they are loading and offloading trucks, and most of their forklifts are battery powered. So in an installation like that, they can take their existing grid-tied inverter, put in a 100 kilowatt LSP with batteries. They can use the excess PV that they're generating during the day to charge those batteries, and then in the mornings at 4, when the operations are starting up, they can actually discharge the batteries and save on their energy costs. And that's essentially how it works. All right, so you cannot power any essential loads directly off the inverter, but you can discharge the batteries. As long as the grid is available, you can discharge the batteries to your grid-tied inverter, which will then invert power to load. All right, so that's a wrap for today, guys. I see I think we've covered all the questions, so I want to thank each and every one of you for joining today, guys. Keep up with the sales, and thank you for your support, and we'll see you in the next video. Thank you.